Alright, Chapter 7, Modeling with Primary Features. Chapter helps you identify the features and use in situations in case of the features to avoid, which helps to evaluate the feature best used particular job. With some features, it's clear when to use them, but not others. The chapter guides you through the decision-making process. I have split the list of SolidWorks features into two groups: primary features, secondary features. Primary features are, of course, one of the most frequent. In this chapter, you will learn to understand details of extrude, understand details of revolve, understand complex solid features, understand different fillet types. Identify when to use which tool. I always try to think of the alternative ways to do it. It's important to have backup plan, or sometimes multiple backup plans. In this case, a feature that does not perform, especially the way you want it to perform an exercise, often try to see how many different ways a particular shape might be modeled. How each modeling method relates to the manufacturing method, cost, editability, efficiency, and so on. You may also want to try to approach this for fun and education if you are familiar only with the standard half dozen or more use or so most used features. Your options are limited. Sometimes simple features truly are correct ones to use, but using them because they are only the things you know, it's not always the best approach. Alright, using extrude feature. Extrude features can be grouped in several categories: extruded boss and cut features as high level and at the highest level. You can extrude closed loop, sketches, regions, in some cases faces. You can extrude face, offset, or plane. Extrude features can also be made in one direction, two direction, or mid plane. Drafting is an open option with extruded features. Creation of a solid feature. In this case, the term solid feature used the opposite with a thin feature. Solid feature is the default when you extrude a closed loop sketch. Closed loop sketch fully encloses any area without gaps, overlapping sketches at any endpoints. Figure 710 shows the closed loop sketch and creating an extruded solid feature. 7.1 closed loop sketch, extruded solid feature. Creating a thin feature. Thin feature options are available in several of the features, but most commonly used with the extruded boss feature. The features are created with the default when using open loop sketches. But you can also select the thin feature options, closed loop sketches, and sketches which mixed type. Thin features are commonly used for ribs, thin walls, hollow bosses, and many other types of features of the common to plastic part casting or sheet metal. Even experienced users tend to forget the feature for not just for bosses, but they can only be used that they can only be used for cuts. For example, you can easily create grooves and slots with thin feature creates. Figure 7.2 shows the feature for the addition with the default options available for the extruded feature for the feature, its thickness, dimension, as well as three options to direct the thickness relative to the sketch: one direction, mid-plane, and two direction. Two direction option requires two dimensions. You can create a cube with a single sketch line thin feature extruded. However, because they are most specialized in some of the respect, the thin features may not be flexible when designing indent changes. For example, if you part going to from a constant width to tapered or a step shape, thin features will not handle this kind of change. Figure 7.2 shows the different types of geometry that are typically created from thin features. Figure 7.2 shows different types of geometry created with a thin feature extrude. Alright, understanding workflow. SolidWorks often multiple ways to do this in most functions. Most of the time, no way for the better than others. Having lots of ways to do this, I think, makes remembering ways to do easily. But sometimes it's hard to teach or learn because of the option get it overwhelmed quickly. My suggestion is find a way that works for you and use it. Learn other ways if something stops working for you. Here's an example: extrude feature workflow, other several options. From with an active sketch, appropriate geometry, click extrude toolbar, select the extrude feature option, click OK, or with no sketch activity, click on the extrude toolbar icon, select existing sketch, appropriate geometry, set the extrude feature options, click OK, or with no sketch active, click extrude toolbar, select a plane which to create the sketch to extrude, create the secure sketch, exit the sketch using confirmation corner icon, set the extrude feature options, click OK. Different types of feature geometry require different types of sketches. Shown figure 7.3, a sketch type can be some sketch types cannot be used directly for making features at all. They may be used as reference, closed, open, nested contours, or types of you can probably use the most in SolidWorks. So we shows closed contest, open construction contour, open contour, nested contour, double nested contour, self-intersecting contour, open and closed contour, wrongly shaped endpoints. In addition, with extruding 2D sketches, Solidworks can extrude 3D sketches. Solidworks will automatically fill the 3D sketch to form a solid face. You need to determine the direction, such as the plane. The plane normally use the direction, edge line, or axis shown in 4. So now we're picking the extruded laid 3D sketch, direction, blind, depth, line thickness, merge, result, lofting, draft, toward, direction, selected contours, configurations. Using end condition. End conditions control how the extrude start, stop. In most situations, extrude starts whether the sketch plane goes to a specified distance, but there are other options. Start condition. From sketch plane, from offset, distance, vertex, from selected plane, from 3D sketch, from selected face, end condition. Distance, blind, through all, up to the furthest face, up to selected vertex, up to selected surface, offset from surface either near or far, offset, or either offset or translated. Up to selected body, midplane, divide distance in half about starting plane direction. Addition start end conditions, you control the direction of the extrude. If you want to push the profile along with the curve, you can easily revolve or sweep as appropriate, with both covered later in this chapter. Understanding instant 3D, and that shows the pull arrow with a measuring stick. Instant 3D tool enables you to use the mouse to pull arrows, handles on the screen, change the various dimension parameters for features, extrude, revolve, fillet, and even move face. Not every dimension parameter is editable in this way. In some cases, the Instant 3D offers a convenient way to edit geometry without needing to figure out which feature is responsible for which face. With Instant 3D, you simply pull on the hands of the screen to move the resized sketch, and features include fillets. To me, Instant 3D gimmick that tries to imitate direct edit software without actual benefits of the direct edit software. If you want direct edit software, you need to get different software. Useful Instant 3D is probably limited to the concept modeling and quickly loose-like models. I just want to make sure that no one confuses Instant 3D with actual direct editing, as SolidWorks marketing seems to try to do. Alright, then you see the revolve circle with the axis through it on the left. Working with a revolve feature like others, revolve feature has some rules you must observe. Choosing sketches to create a revolve. Use any type of line and model edge of the center line, not just the center line construction line type. If there's only one actual center construction line in the sketch, it will automatically be used as the axis for revolution. Draw only half of the revolving profile. Draw the section one side of the center line. Profile must not cross center line. Profile must not touch center line single point. If it touches along the line, not at pointing, revolving sketches touch center line single point would create a 0.0 thickness in this part. Understanding end conditions. 5 revolve end conditions, blind up to vertex, up to surface, offset from the surface of mid-plane. There is no consider equivalent to up next to, up to body with a revolve feature when figure 7.5 shows revolve properties. Shows axis revolution, direction, and feature and selected contours. Workflow. The workflow of the revolve feature, create a sketch involved with the revolve feature. Select an axis, typical construction line, select end conditions, select OK. Using contour selection. Like extruded feature, revolve feature can also be the contour selection. Extrude with the features are recommended. You can use the contour production. Introducing loft, boundary, and sweep. Sweep, loft, and boundary known as interpolated features. These means you can create profile features certain points off where interpolate the shape between the profile. You can use additional controls, loft, such as guide curve center lines, and establish end conditions to help direct the shape. A loft is just 2 profiles in a straight line transition. If you have more than 2 profiles, the transition from one profile to another works more like a spline. Many other users struggle when faced with this option to create a loft, the boundary, or sweep. Some overlap the existing among the 3 features. Even the gain in some experience, it becomes easier to choose among them. Generally, if you create the cross-section of the feature manipulating with a dimension single sketch, the sweep might be the best feature. In cross-section, change the character several changes shape, left boundary may be best. If you need not very different shape at both ends or in the middle or loft boundary, a better choice because of the enable to explicitly define the cross-section at any point. However, the outline is more important than the cross-section. You should choose a sweep. And in addition, if the path between the end is important, choose a sweep. Both types of features are extremely powerful. Sweep has a tendency to be a fusser about detailed setup and rules, although loft and boundary can be surprisingly flexible. I'm not trying to dissuade you from using sweeps because they are useful in many situations. However, in my own modeling, I probably use about 10 loft boundary features for every sweep. For example, although you would use the loft combination loft feature to create the outer face of a complex laundry detergent bottle, you would use a sweep to control a raised border around the label or area of the cap thread. A good example, interpolated nature of loft is putting a circle in one plane and then a rectangle in the offset plane, and then lofting them together. The arrangement shown in Figure 7.6. So here's a circle and a rectangle, and they've been lofted together. Interpolation side loft. Transition between shape of the defined characteristic loft region with a chosen loft inside of another feature. The loft can create both pause features and cut features. Notice how the cross-sectional shape of lofts transition circles into rectangle with the default setting. Interpolated transportation happens evenly across the loft of the distribution chain, with at one end of the other could be altered, while might result in transition shown in some 7. Adding ending conditions loft alters interpolation distributed, and it shows a profile sketch 1 and 2, start endpoints, normal to profile, degrees, direction, apply constraint, normal, end constraint, degrees, direction, apply to wall. Both shapes do profile loft. The two profile loft with the default end condition also create the straight transition shown in Figure 7.6. 2-point spline with no end of the tangent creates the straight line exactly the same way. By applying end conditions to either of both the loft profile of the loft shape is made by interesting shown in Figure 7.7. Again, same thing happens applying with the end tangent conditions with the 2-point spline, and it goes from being straight line to being more curvature and continuously variable through curvature. Comparing loft and boundary features. Important difference between boundary and loft that there is more option with setting up of the boundary feature within term geometrical layout and with the profile and with the guide curves. The second major difference is that there are no profiles guide curve with the boundary. Two directions are treated equally. They are simply called direction 1, direction 2. In the loft feature, you don't have so much continuity across the guide curvature direction. This is less meaningful with the solid features within when surfaces. In fact, boundary features usually far less than other than surfacing related cuts on boundary surface. In geometrical layout, profile is the most important difference between a boundary and a loft. With the loft, you must profile at the beginning and the end of the feature. With boundary, you can lay out the profile sketch planes like an X. You could use all features out like a T, which would act like a sweep. Using layout shaped with the F actually combines the functionality of a loft with that a sweep of the boundary. Very powerful feature option for creating interpolated solid shape face by face control. However, still more than using surface boundaries. Figure 7 and 8 show features of X and F and X layout. Sketches F layout resembles letter F. Sketch lines planes X, Z, Y, Z, X, Y, and plane 1. The X layout uses the sketch right, Y, Z, and plane 2. These two features represent stretch layouts that you can use in loft features. Alright, so we have different profile arrangement boundaries. We've come with plane 1, 2, front X and X, and right Y, Z, plane, and then front plane 1, X, X, none, and X, Y, plane, and this was done with a boundary feature. Loft does have two conditions boundary cannot answer. Centering line loft, all boundaries must intersect. Closed loop off without direction 2 guides. To make closed loop boundary, you must have direction 2 that intersects direction curve 1. That's two conditions that the boundary cannot answer. Using etnies and loft. For solid lofts, you can select the face of closed loop 2D, 3 sketch the surface of the bodies. You can use the sketch point profile for the end of the loft that comes to a point with a rounder end. For surface of lofts, you can use the open sketch for the edge for the addition with the end of the use for the solid lofts, but you cannot combine one and open and closed contours. Some specially functional because they're available to you with the all profiles guide with the curves together in a single 3D sketch. In order to select the profile made in this way, you must use Selection Manager, but as discussed later in this chapter. Sketch tool panels of the loft property manager enables you to drag the sketch at need of the profile made while you are editing, creating loft feature without need to exit and edit the sketch. I discussed 3D sketches more detailed chapter 6. Get more from your sketches. Compare loft and splines. The word loft and spline comes from the shipbuilding trade. The word spline is actually defined as slats of wood that cover the ship. The ribs of the hull vary much more resemble loft sections, splines, and slats bending at each rib. Each is easy to see how the modern CAD analogy came to be. Loft and splines are governed by similar mathematics. You have seen how 2-point splines and 2-profile loft both create a straight line transition. Next, a third profile is added to the loft, a third point and a third point to a spline, which demonstrates how the math that governs splines and lofts are related to bending in a elastic material. Figure 7 to 9 shows how loft and splines react geometry in the same way with a bending flexible steel rod would react, except that spline and loft do not have the fixed length. 3-point spline, no end conditions. End tendency change. Reacts lines pin joint. Notice slightly bulge just like a real rod in bending. And this gives you profile sketch 2. With this bit of background, it's time to move forward and talk about a few major aspects of the law features Solidworks. In this single chapter, I don't have the space to cover the topic exhaustively, but coverage more major concepts will be enough to point you in the right direction. Control sweep features. Sweep features generally give you the multiple sketch of the sweep that's made for the profile cross-section path that can create a boss or cut feature you want to. You can use the guide. Curved sweeps can use the run the gamut with a simple complex. Simple sweeps are used to create wiring, tubing, and hosing. Sweeps that more complex are used to create objects such as bottles, involts, springs, and screws. Main creation selection sweep to create a curve that must be able to identify with the cross-section path. The profile cross-section section can change along with the path, but overall the shape must remain the same. Profile typically perpendicular to the path, although this is not a requirement. Recent addition in software included the option Sweep Property Manager for a circular profile. This is for simple sweeps of circle drawn along a path, but by its center and maintaining constant diameter, such as wire, hose pipe, and so on. Uses functions specified with the diameter of the circle and the property manager. Using a simple sweep. An example of simple sweep shown in figure 17 with the paperclip uses circle as a profile, coiled lines, arc as a path. Sample sweeps keep in the same size and shape profile along the entire path. The sweep could be used previously mentioned option for a circle profile shown in figure 710. So we have profile of the cross section, you're given a circle to it, and we follow the sweep path. Using the sweep path guide covers sweeps that have the more complex, beginning with the control size, orientation, position, cross section travel through the sweep. You can guide with the curve. Several angles can be used to visualize the sweep works. Cross section profile curve. Solve with several intermediate positions along the path. The guide curve does not follow the path. The difference between the two is made up of adjusting profile. Consider the following example. In this case, the profile is an ellipse. The path is a straight line. There is a guide curve. The give of the feature is outer shape. Outer shape figure 711 shows all these elements finished feature. Alright, so now we sweep profiles on the path with control parameter and guide curvatures. We start with profiles, and we started from the top to the bottom, and we've ordered our sketch. We started end constraint with normal to profile with degree and direction apply to one end constraint, normal to profile, degree, and direction 2 apply to all. On the website, the part shown in 711 is downloaded materials in Wiley website chapter with the under file name chapter 7 the bottle solid part. Property Manager sweep function includes option for the show of the section, which for this case creates 200 intermediate cross-section sections used behind the scenes of the create a loft. You can think of the complex web sweeps as guide curve with the center lines automated setup with an even more complex loft, helpful to the envision features such as when you're troubleshooting or setting up sweeps that are more complex. Once you open Chapter 7, the bottle solid part, you can edit the sweep feature to examine the section for yourself. Most other published Solidworks material that covers these type sweeps are covered in better lofts because many of the people consider lofts more advanced topic. However, I have put loft first because understanding them is necessary because you understand complex sweeps, because complex sweeps really are just lofts. Using Pierce relation. Pierce sketch relation only sketch relation when applied with 3D out of plane edge and or curve without projection edge of the curve in the sketch plane. The axis of the 3D curve edge and length of the string sketch point is a hole in the center of the bead. Pierce relation is most important sweep feature when applied with a profile sketch between endpoints. Center points of the sketch point out of plane guide curves. This is because of the Pierce relation that determines how a profile sketch will be solved with the move down sweep path to create the intermediate profiles. Figure 712 illustrates function of Pierce relation sweep of the guide curves. The dark section of the lost sweeping section is the sketch. Lighter sketches to the right represent the intermediate profiles that are automatically created behind the scenes and are used internally to create the loft. So we have a guide curve, a Pierce force, a contact, sketch sweep, profile, and this is figure 712. Figure 712 shows the happening behind the scenes of the sweep shape of the sweep recreates the original profile, various points along the path, the guide curve with the case of the force provided with a rebuild with a different shape. Pierce constraints are not required in simple sweeps, but when they are starting to use guide curves, you should also use Pierce. Tip: if you feel that you need more profile control but still want to create a sweep-like feature, try the center loft. Centerline loft. Centerline acts as a sweep path that doesn't touch the profiles, but unlike a sweep, you can use multiple profiles with it. Figure 713 shows a more complicated 3D sweep, both path and guide curve and 3D curves. I cover 3D curves in Chapter 8, selecting secondary features. You can refer to these sections to understand how this part is made. And so this is 3D sweep. On the website of the part shown in Figure 713, the download material Wiley website chapter of the use under file name Chapter 7 3D sweep solid part. The part is created by making a pair of tapered helical with the profile sketch paper plane perpendicular with the end of the one of the curve of the tapered of the outer helix is greater than the inner one, which causes the twist become larger in diameter. It also goes to one up. To make a circle flow with both helixes, you must create with a two Pierce relation, one between the center of the circle and the helix, the other between the sketch point that is placed on the circumference of the circle, other helix. This means the difference of the tapered angles between the two helix for the drive of the chain with the diameter of the sweep. Using a cut sweep with a solid profile cut sweep feature with the option with a solid sweep profile with the kind of functional. It has many uses, but primarily intended for simulating causes complex cuts made of mill and lathe. Figure 714 shows a couple example cuts you can make with this feature. The part used for the screenshot, Chapter 7, cut sweep, solid profile, solid part. Also, as in website downloaded material, can you cuts make the cut sweep feature using solid profile. Solid profile cut sweep has few limitations I need to mention. It requires two bodies to target and cutting tool. The path must start with a point intersecting the solid cutting tool body. Pull path starts inside on the surface of the cutting tool. The path must be tangent with itself, no sharp corners. Cutting tool must be defined with a revolve feature. Cutting tool must be made with simple analytical faces such as sphere, torus, cylinders, or cone. No splines. You cannot guide a curve with a solid profile cut because you cannot control the alignment. The cut intersects itself, but the path cannot cross itself. You can create many useful shapes, solid profile cut sweep because some of the limitations I've listed. Some of the shapes are more difficult to create than others. For shapes, you might choose the regular cut sweep features. Workflow. Using the following general steps to create a sweep feature. Create the path first, attempting to create with the profile first for the general rule. Create the path first. Attempting to create a profile first, but the general rule thing is to work out better if you think of the path first. Create guide curves. Again, working out better if you create them before a profile. Create a profile sweep cross section related to the path with a Pierce sketch relation. Select a point with sweep profile that you want to driven down on the path as beads following a string. Maintain sure of the profile with driven down with the path while the profile sketch plane with the maintaining original relationship with the path with the profile. Flexibility change ways needed change. Sketch is reevaluated at each point along the path using relative relation, parallel, perpendicular, and so on instead of the absolute ones, horizontal, vertical, and fixed. Start sweep feature for the toolbar menu. All sketches must be closed. Select profile first and then path. Solidworks automatically toggles from the profile selection box, path selection box as soon as profile is selected. So take advantage of the automation to help you work quickly. Note the circle profile is centered on the path. There is no longer need to create a sketch. Caution, pay attention to any of the tooltips, warning, error messages that come up if unable to select something, usually because something about the is inappropriate for the purpose that you're trying to assign it. 7. Use a preview to check the performing the way you want it. Click OK when you feel satisfied with the result. Understanding fillet types. Understanding fillet types. SolidWorks offers very powerful filleting functions. Fillet feature comprise various types of fillets and blends, simple fillets and straight and round edges with the handled differently from various radiated fillets with the handled differently with a single double hold line fillet or in setback fillets. After you click the OK button, create the fillet a certain type, you can switch into another type. You can switch types only before you actually create the feature. Many filleting options are available, but most of them are selling use even known. In fact, most users find themselves with the constant radius, variable radius fillets. These sections describe all the available fillet types options. Constant size, symmetrical fillet, circle, not conic row, conic radius. Curvature, continuous, symmetric fillet, elliptical, conic row, curvature, continuous, multiple radius fillet, round corners, keep edge, keep surface, keep feature, variable size fillet, face fillet, curvature, continuous fillet, face fillet with a help point, single hold line fillet, double hold line fillet, constant width fillet, full round fillet, setback fillet with variable radius. Figure 715 show the fillet property manager. Note that the SolidWorks does not distinguish between fillets and rounds, and even two edges were selected for the use of the same fillet feature can have the opposite function. For example, both adding and removing the material in a single feature. Shows the fillet property manager, manual fillet expert, and the different types of fillets. Many items in the show the selection of tangent, propagation, fillet, partial, preview, fillet parameters, radius, multi-radius fillet profile, setback parameters, and then set all fill options, select through faces, keep corners, round corners, overfill, default, keep edge surfaces, creating constant size fillet. Constant size fillets are most common types that are created with the using select edge feature faces for the changing any settings. You can select the features and faces that cause a large number of fillets to be applied. User consider several of the best practice guidelines and other recommendations that come later in this chapter. Select entities to fillet. You create the fillets. You can create fillets with several selections, including edges, faces, features, and loops. Edges offer a most direct method, easier to control. Figure 716 shows how you can use each of these selections, create fillets on most part of them more intelligently. Tip: you must select feature of the fillet with the feature manager for the selection filter features. Only edge of the face of fillet selection. You can select the loops in two ways: through right-clicking selection loop option and select face and control select edge on face. Another option, selecting edge and fillet command and select through the faces option, which appears in the fillet option panel. The option enables you to select edges that are hidden by the model. This can be used option on part of the few hidden edges. It can be detrimental to option on part where there are many edges due to patterns of ribs, vents, existing fillets. You can control a similar and global feature for the other than fillets by choosing tool option, display selection, allow selection, hidden lines removed, and shade modes. Figure 716 shows selecting option of fillets, selecting individual edges, selecting faces, fillet edge, round faces, selecting feature fillets, edges touching the feature, selecting loop just as a shortcut, selecting several edges. Face and feature selection also useful for creating fillets as you want to use in selection update. Figure 716 of the ribs intersection select your bosses also being filleted. The ribs do not exist when the fillet is applied but added later reordered, and so it can be before a fillet feature. And fillet selection automatically considers the rib. The fillet used in the edge selection automatic selection update would not take place. Alright, using tangent propagation. By default, fillets with the tangent propagation option term with a usually good choice for all through. Many times the experiment with turning it off. Tangent propagation simply means that selecting edge of the fillet, the edge of the tangent, other edges that the fillet keeps going along the tangent edges until the closed loop of the tangent edge stops or fillet fails. If you deselect the tangent propagation but there is still tangent edges, you may see the different result with the impossible result that could fail. One of the trick fillet features is to try to envision what you're asking the software to do. For example, the one edge fillet but the next edge is not. Then how the fillet is going to end. Figure 717 shows the two potential result of the fillet's asked not to propagate. The fillet face may continue along its path until it runs off the part until the feature fails. Deselecting tangent propagation. Tip: this may sound counterintuitive, but sometimes the fillet feature fails. That may be useful to deselect propagation. Make the fillet with a multiple feature for their times of creating two fillets, like the one shown in figure 717 works time to making the same geometry. Single with a single feature will not. This may be due to geometry problems with where sharp edges come together and are eliminated by fillet. Best practice in general, fillet should be the last feature applied to the model, particularly with a small cosmetic edge break fillets. For large fillets contributed with a structural overall shaped part may be applied earlier. Be careful of the rock, paper, scissors game and inevitably are caught up with the model plastic parts deciding on the feature of order, fillet, drafting, or shell. Most fillets should come after draft. The large fillet should come before shell. Draft may either be before or after the shell, depending on the needs or area of the dealing with the part. In short, there are no single set of the rules consistently applied with the works best in all situations. Dealing with large number of fillets, figure 718 show the model with a bit of filleting nightmare. The large plastic tray requires many ribs underneath the strength. Because the ribs may be touched by the user, sharp edges need to be rounded. Interior edges are needed to be rounded. Strength of the plastic flow through ribs. Literally hundreds of edges will need selected to create the fillet if you do not use advanced technique. Alright, 718 shows a plastic tray with a large number of fillet skillet selecting etnies. Some of the techniques outlined previously, such as face and feature selection, can be useful with a quick filtering. A large number of the edges of the meet the same criteria with another method. Window selection is option effectively if you want a first position model with a view. Only the corrective edges will be selected. Turn off, select through the face option, and use the edge selection filter. First option, fillet property manager selection toolbar. The toolbar highlights several selection option-based types of selection similar with the initial selection. For example, if you select an edge, selection toolbar might highlight edges parallel to the selected edge face with a touch. The selected edge stand selected edge. Using Fillet Expert. Fillet Expert automatically finds the solution complex of the fillet problem, partially for the problem that can arrive that have several fillets different sizes coming together. It allows you to select with a multiple edge part. The one shown in figure 718, ideal for the tool. Use Fillet Expert. Click with the Fillet Expert button. Fillet Property Manager 719. Use Select Edge of Fillet Expert. Presents pop-up toolbar. Given the several selection options. Those figures 719 show the majority of the edges selected needed for the fillet. The same type of the functionality you would find in the selection toolbar in the fact. Selection toolbar toggle is found in the Fillet Expert Property Manager phone and shown in 719. Corner tab of the Fillet Expert enables you to select the different corner options which are useful. Result with the different file orders. Corner Expert, make sure the Fillet Expert is active, then click the corner in through the toggle through options. Using preview. I like the fillet preview. It helps you see what fillet would look like. Perhaps more important presence of the preview usually, but not always means the fillet will work. Fortunately, when you have a large number of fillets to create, the preview can cause significant slowdown. Deselecting using partial preview are both possible options. Partial preview show the fillet only on one edge. The selection is much faster when creating a large number of fillets. Figure 719 is the Fillet Expert selection technique. Manual fillet, add, change your corner. Items to fillet, show the selection bar, radius. Applies, option select through, face, tangent, propagation, full preview, partial or no preview. Performance for rebuild, speeds, efficiency should make fillets with the minimum number of features. For example, you'll have 100 edge fillet with better performance to do with a single feature for that. Feature that has 100 edges selected rather than 100 fillet features that have one edge selected. This one case when creating a feature for the rebuilding feature, both faster choosing a particular technique, usually faster create the rebuild more slowly. Best practice, although creation rebuild speed with a sync will give the minimum number of the feature for the create the maximum number of fillets. This is not usual with a high end. There had to be downside with a single feature for the large section where only one of these edges that fails to feed will cause the entire feature to fail. As a result, features 100 edges selected 100 times more likely to fail than features single edge. Large selection sets are also more difficult to troubleshoot when they fail more than small section set fail. Using folders. When you have a large number of fillet features, you can be tedious to navigate the feature menu. Therefore, useful place group of the fillets into folders. This makes it easy to suppress unsuppressed fillets in a folder at once. Separate folders can be partially used in fillets for the different uses. Such fillets are used by Solidworks models and fillets for the removal of the fine element analysis or drawings. Folders are also allow the bulk section such features that save in the selection sets. Making multiple fillet sizes. Multiple radius fillets option. Fillet Property Manager enables you to make multiple fillet sizes with a single fillet feature. Figures 720 show the multiple radius fillet feature of loop locks when you're working with it. Changes value of the call out flags or in Property Manager. Although you may see small performance benefit considering condensing several features into one may downside adversely affect the performance. Lose control of the feature or a single failed fillet causes the whole feature, therefore all fillets to fail. Troubleshooting is more difficult. Small groups of fillets can be suppressed without suppressing everything. You cannot change the size of the group of fillets together. Best practice. Although it may not be personal opinion within best practice, I believe there are good reason for the conservative techniques other than signal feature for that contain many of the fillets and single feature for the drive fillets of various sizes. The best practice would be to learn more toward grouping fillets than have the similar use of the same size. For example, if you want a separate fillet for the break the corners on the ribs of the fillet round with the outer shape of the large plastic, after consideration feature order which comes fillet relationship with the draft shelf with the feature of the fillets are grouped in single feature with the controlling relationship which becomes immediate impossible. Rounding corners are option when they refers to Solidworks handles fillets going around sharp corners by default and setting off, which leave the fillet under sharp corners looking like mitered picture frames. In turn, setting on the corners look like marble have rolled around it in figure 721. Shows resulting geometry in both settings. Rounded corners off, rounded corners on. Using keep edge and surface toggle. Keep edge, keep surface toggle determines Solidworks should do if the fillet is too big to fit in the air with a keep the edge for the option with the edge where it was. Tweak position not the radius of the fillet to make it meet the edge. The keep surface the option, keep the surface of the fillet in the face clean. However it does do this, it has to tweak the edge often with the trade-off with the take. Try to play fillets in this place if it is too small. Sometimes it's useful to visualize what you think the result should look like. 722 shows how the fillet would look in a perfect world. 5 with the fillet looks when cramped with the keep edge option. How to look with the cramped and keep surface option. Default option. Choose the best option in particular situation. As a result, it seems to you with the keep edge option unless it does not work, in which case the change to the keep surface option. Using keep feature option. Keep feature option appears in fillet option panel. Fillet property manager. Default option is turned on. If fillets around with the feature such as a hole, as long as if it's not through the hole of the boss, these selections keep the feature option, remove the hole and the boss. Keeping feature is selected the face of the feature, trim and extend with the match of the fillet is shown in figure 723. 722 show the keep edge and keep on surface features. Keep fillet option, select through the face, keep feature round corners default, keep edge, keep surface, keep fillets, keep select through for keep fillet round corners, keep surface. Keep feature option both selected, unselect them as part before fillet. Keep feature on fillet. Keep feature off. Using symmetric, asymmetric fillets. Standard fillets with symmetrical either side of the selected edge. Asymmetrical fillet can have a different radius on either side of the selected edge. This makes for the more complex looking fillet. May also complicate with the troubleshooting complex part. Figure 724 illustrates the concept of some asymmetrical fillets along with the fillet parameters panel. Fillet property manager associated with the specifying the type of the fillet. A symmetric fillet can be used with various radius fillets described later in this chapter. In addition, specifying 2 radius values, you can also flip the side of the values using the opposing arrows icon. Asymmetrical fillet, and then show the radiuses and profile. Selecting fillet profile with symmetric, asymmetric, you have the sum of the profile options. Circular only, symmetrical, elliptical only, symmetric, conic row, symmetrical, asymmetrical, conic radius only, symmetrical, curvature conditions, symmetric, asymmetric. You can think of these profiles being fillet cross-section, circular cross-section can be defined with single radius. They should be intuitive senses. You should be familiar with the shape of the lips, although they're not directly specifically with the radius valuable. Solidworks radius value approximate cross-section found in 725. Shows a circular, conic radius, conic radius, curvature, continuous, elliptical. Circle profile or normal type of the fillet with a specified single radius. This is what we think of the default for. The elliptical profile is available only when specifying an asymmetric fillet. 2 radius value determine the ellipse which is around the selected edge instead of the usual arc. Conic row profile of the row or the P noted symbol conic number refers to the conic section in the classic geometry circle ellipse of the hyperbolic parabola has driven with the parameter rho with the many other CAD systems. Rho runs from 0 between 0 and 1. Figure 726 show the effective range. Row values profile with the fillet. If you want the experiment with it, the file can be either created with the screen capture down the material file with a conic row fillet side part. Conic radius profile is specified by the main radius value. Conic radius value can be either the positive number. Conic radius value radius conic section curve at the shoulder, which in this case means middle of the curve. This works in a way similar to the rho value, but the range effect is similar to what you see in Figure 726. Conservative continuous profile available to one edge selected fillets. The newly previously curvature continuity was available only on face fillets. Next, the curvature continuity is a spline-based profile with a match of the curvature face on either side of the selected edge. Edge selected C2 fillet is being conveniency over need of the select edge. An old C2 fillet cut fillets you should still work by going forward. In most cases, edges selected fillets will be easier. Continuing curvature face fillet. Curvature continuity refers to the quality of the transition between two curves and faces, whether the curvature is same continuous around the transition. Best way to convey the concept of the simple 2D sketch for the line transition to arc. Non-continuous curvature line. Non-curvature with the abrupt change of the because of the arc has a specific radius inverse of the curvature. R is 1 over C. The straight line R is equal to infinity of the minus the inch, in which case the C is O. To make transition R infinity into R smoothly, you need to use the variable radius such if the thing existed. Several types of switch geometry: variable curvature, ellipses, parabola splines, ellipses, parabola file, the mathematical formats create shape, but splines in general curve that can take it any shape they want. When you control the curvature, change the smooth of the continuously splines, thereby vary definition. Have continuous curvature with a spline, although you cannot control the specific curvature or radius values directly. All this means continuous curvature fillets use spline-based profile for the fillet rather than a circular or elliptical. Illustrates the difference between continuous curvature and a constant for the spike of the top curves represent the curvature of 1 over R. Some of the smaller radius and taller spikes are called curvature comb. Curvature combs evaluate transition lines, arc non-continuous lines, and spline continuous. Some of these fillet profile options must be esoteric or to you, but there are people who are glad to have these options. The options are available in some of the other CAD programs. Creating variable radius fillets. Variable radius fillets are other powerful weapon fillet against boring design. They are also doubly useful to solve the certain fillet problems they arise. Best practice must be easier to identify when not to use the variable radius fillet. Fillets are generally used with a round break edge. When I sculpt the part with even the fillet sculpt the blocky part with not actively trying to make blocky parts with a big fillet. May want to consider another approach, use the complex model which give the better shape and makes it the more controllable. Other options exist to give you a different type of control, such as the double hold line fillet. Applying the values. When we first select the edge of variable radius fillet with the endpoint identified with the call-out flag's value of the unassigned of the previous view does not display until at least one of the points has been radius and the value in the box. You can also apply the radius value in the property manager, but they are easier to keep track of using call-outs. Figure 728, use variable radius fillet. After the edge selection, one of the value has been applied. After the three values have been applied, to apply with the radius value is not any point of the edge. You can select one of the three colored dots along the selected edge. The preview shows you how to fill it will look like in a wireframe display. By default, variable radius fillet have the tied points on the edge, one at each endpoint, one at the midpoint, one on each half between the endpoints in the middle. If you want to create the additional control, there are three ways to do it. Control drag existing point, select the call out with the existing point, change the P percentage value. Note, change the number of the instance value variable radius parameters panel of the property manager. Figure 728 assigns the value of the variable fillet radius. This is unassigned variable radius, and variable radius unassigned. Variable radius, and then your radius over P percentage. If you selected several edges, several unassigned values are screened, you can set the unassigned option. Property manager to set the same value, but to set all option radius values same number, including any values that may have the change of a different type of the rest. Figure 729 shows variable radius parameters and panels. Parameters panel. Symmetric, and then show the different variable set radiuses, profiles, number, smooth transition, straight transition. You can send the end of the variable radius fillet value 0, but you need to be careful because it looks like it could cause downstream problems. The other fillet shells offset even matching operations cannot assign 0 fillets in the middle of the edge, only at the end. If you can need an end of the fillet with a particular location, use the split line split edge. Apply 0 radius at the point. Chapter 8, selecting secondary features, cover the split lines, and figure 730 shows the 2 0 radius values. So 730 shows the 2 radius value, various fillet values. The image on the right shows the instant 3D, usually with the edit variable radius fillet. Select the fillet with the face for the instant 3D turned on. Blue dots appear with the radius value assigned. You can move these dots dynamically, edit with the corresponding value of the variable radius. Using strategy versus smooth transition. Variable radius have the option either straight transition, smooth transition. The works like to profile off mentioned earlier in the chapter. The main name means somewhat misleading. Both transitions are smooth. Straight transition goes into a straight line from one side to the next. Smooth transition goes in a swooping S-shaped path between the sizes. Between the two transitions demonstrated in 731. Smooth transition, straight transition, recognizing other use of the variable radius fillets. Variable radius fillet, the different method to create fillet, generally default continuous radius fillet. Sometimes use various radius can make a difference where constant radius fillet does not work. Sometimes use even variable radius fillet is just another tool in the toolbox. Using face fillets. Face fillets may be the more flexible type because of the range with which they can do. Face fillets start simply with the alternative selection technique with the continuous radius fillets extend with extremely flexible double hold line face fillet, which is more than a bend of the fillet, usually normal construction circumstance of the default fillet type selection edge of the create with a fillet with the edges used because of the represented intersection between two faces. However, sometimes the problem edge of not being clean with the broken to a smaller piece than any number of the other reasons for the causing constant radius fillet use the edge selection to the fail. In this case, like Solidworks display with the error message failed to create fillet, please check with the input geometry radius values trying to use face fillet option. User almost universally ignore the message situation shown in Figure 732. Face fillet suggests the error is message is exactly one that should use. Here the face fillet covers overall the junk edge of the prevents the fillet from being executed. Should fillet manage we push face fillet, face 1, face 2, tangent, full preview, partial, symmetric, radius, and circle. Face fillet sometimes made and cover over the mass geometry, but they might think of it as never fillet with the main limited. Fillet typically with the fillet may be bigger enough to bridge the gap. The right with the big enough for the face fillet to fail. If they are too small or too large, show complex fillet, situation complex, and face fillet. Alright, on the website of the model used for the image can be found with the download material Wiley website. The chapter look for file name Chapter 7 plastic cover fillet solid part. Using the face fillet with the help point. With the help point with the face fillet property brand is fairly obscure option. However, it's useful case for the selection 2 face that does not uniquely identify the edge to fillet for. Example figure 734 shows the situation with the selection 2 face could result in either one of the edge or other being filleted. Normally, I would hope both edges will be filleted. The fillet would default with one edge to the other, but you can force it into a finite edge using the help point. In some cases, the help point is all ignored altogether. For example, in simple box and select both ends of the box selection, set 1, top box selection 2. Fillet could go to either end. Consequently, assigning help point will do anything because the multiple faces have been selected to determine the factor which for the multiple faces being selected first. If there was more commonly used feature for the interface might be made like little less cryptic. But because the features rarely is ever used, it should just become a quickly piece of trivia. Applying a single hold line fillet, single hold line form to various radius fillet rather than the radius being driven with the cylindrical numerical values driven the hold line edge of the model. Hold lines can be with the existing edge forcing the fillet right up at the edge of the part created by a split line, which enables you to drive the fillet however you like. Figure 715 shows the two options before after fillets. None of the fillets are still arc-based fillets. If they were to take a cross-section perpendicular edge between the fillet faces, it would be an arc cross-section distant radius. However, the other direction hold line fillet does not necessarily have a constant radius, although it may hold the line parallel to the edge between the faces. So now we've picked on the help point face fillet. And that's down there in fillet options. You have a hold line edge, hold line split line. You can select hold line fillet option, panel face fillet, property manager of the tool panel fillet type available. The feature first created with the edit after it has been created. Fillet type panel does not appear. As a result, you can change from one top level to fillet to another having been initially created. You have the double hold line fillet. Sometimes a single hold line does not meet your needs. Single hold line controls only one side of the fillet. In order to control both sides of the fillet, you must use the double hold line. Solidworks software does not specifically differentiate between single and double hold line fillets, but they're radically different how to create geometry with both sides of the fillet controlled and not possible to span between the hold lines with the arc that is in tangent both sides unless we're careful of setting up the hold lines so they are equal distance edge wedges from when the face intersect. Let's move the double hold line fillet must be used spline. The span between the hold lines shown in figure 729-36. Double hold line arc spline cross section arc tangent both the ends does not fit together. Spline tangent on both ends fits. Here the feature you need to use the curvature continuous option fillet with the option. Remember that the option creates the spline based on fillet rather than an arc based fillet with exactly what it need with the double hold line fillet. With this make with the double hold line fillet with more blend with the true fillet. Requirement not obvious. Most user may not even document within SolidWorks help, nor is exactly an initiative to get double hold line fillet worked. You must curvature continuous option 737 shows example of the double hold line fillet. Using constant width fillet option face fillet property manager drive the fillet would rather than it be rated more helpful on parts angle with the face between you and the fillet changing dramatically. Figure 738 illustrates the two situations, particularly with a useful setting of the constraint found with the options of face fill with the property manager part shown in images can now be downloaded material. Shepherd in constant one solid part. Example of double hold line fillet. Constant width fillet. No fillet, default fillet, face fillet with constant width option. Applying a full round fillet. To create a full round fillet, you must select 3 sets of faces, usually 1 face each set with a sufficient fill tangent, 3 sets of faces, middle set, end of the face completely eliminated. Figure 739 shows the double application full round fillet. Notice that they're not limited to square block, but also propagates around the tangent. Endings can be created variable radius fillet, irregularly lofted geometry. Full round fillet, and that's over here on the fillet type. The faces of shows 3 faces, tangent propagation, full partial, no view. No, beware, special workflow assisting options exist with full round fillet. After selecting a face, you right click and advance for the next selection. If you're already on the last selection box, you can click OK, finish the feature. You might instinctively reach the tab key, but remember, look at the cursor file with the backward green L-shaped curve for the check mark. Alright, building a setback fillet. Setback fillet mode, complex fillet option key with the setback stop in conjunction with continuous radius, multiple radius, variable radius fillet type. Setback fillet blends several fillets together, single vertex, starting with the blended setback distance each along the fillet edge of the vertex. At least 3, often more edges come together the setback vertex. Figure 740 show for the property manager interface what the finished setback looks like. Following step demonstrates how to use the setback fillet. These setback vertices, all vertices and the vertices will be filleted. Set of the setback fillet time, sometime especially with just learning about this feature, special values, fillet radius, selected edge of vertices, specify 3 setback distance every vertices. Using multiple radius fillets varies for fillets becomes even larger tasks and error steps. Determine the type of the fillet, constant radius, multiple radius, variable radius, assign the selected edge filleted. The select edges must all touch one of the setback vertices, which will be selected at the later step. Assign radius value filleted items shown in sample part illustrates this step. Select the setback vertices in the setback parameter panel with the property manager with the second box with the top highlighted. Select the vertices all below the box size if it's only big enough for the single selection. It can be a multiple selections. Enter setback values shown in figure 742. Setback call-out flags leaders that point in the specific value, specific edge. Alternatively, you could use the set unassigned option similar way how they use various radius fillet interface dimension with the distance shown on the right. Most image figure 742 setback distance over with the fillet will depend on the corner of the fillet. Caution when selecting multiple variables of the preview arrows indicate which edge you are currently setting the setback value may indicate incorrect. The arrows can now be shown only on one vertex, so you want to relay on leaders that call out determined with the setback distance you are currently setting. Repeat the process, select the setback vertices using the preview menu with known with the preview the starting setback set values. Don't worry, they're probably not because the feature is going to fail. If you finish typing on the value of the preview returns, you have spent as much time setting up the feature that you'll spend. See preview to disappear, frustrating, however, perspectives will return. Using chamfers, and we can cut the tape there because it's kind of raining and power might go out.